The two parts are going to seem like they don't really go together, and it's the two last things in this section. It's literal equations and dimensional analysis. Okay, so I'm going to start with literal equations, and we're going to go from there and see how we get. We'll see if we need to save dimensional analysis for tomorrow, if we need to do it today. Okay. Your test, though, will be on Wednesday for sure. Either way, it'll be Wednesday.
You're not school on Monday, right?
No. All right. Literal equations. What this means is I've got an equation, okay, and it might be all variables, or it might have multiple variables in it. But I'm going to solve it for one of those variables. So as I solve, I don't get x equals a number. I might get x equals 2y plus 5z divided by k. Okay? There's going to be other things in there. But I have to remember as I go through these, I am still going SADMAP. I am still isolating the variable that I am trying to solve for. Okay? All the same rules still apply. Just because it's variables doesn't mean that you treat it any differently than you would if it was a number. Okay? So let me show you what I'm talking about. We'll start easy. There are two variables here, yes? So, when I solve this, I'm not going to get just a number. I'm going to get a value that has the variable in it, okay? So here, what if I asked you to solve for m? This is what I'm looking to get by itself. Okay, so what I need to do, I'm going back to that SADMAP, right? Is there anything added or subtracted to m that I can get rid of? Look at it. Yeah, the 3n, right? You can move that whole piece. Just because it's got a variable doesn't mean you can't move it. So I'm going to add 3n to both sides. Now, obviously on the left side, that cancels out and leaves me 4m. What happens to the right side? Does it become 11n?
Yes.
No. Why no? They're not like terms. That one doesn't have an n. Be very careful, okay? So you literally, if you can't do it, and you'll hear me say this 100 times, if you can't do it, write it. I can't add 8 and 3n, so I write 8 plus 3n.
So you're not subtracting, you're just moving.
You're just moving it. That's exactly right. If you can't do it, write it. Okay, that's the key for this section. If you can't do it, write it. You need to have like terms before you can combine them, and those are not like terms. Does that make sense? Okay. Now what? Still solving for m, so I'm still getting m by itself. What's hooked to m still? The 4. What is the 4 being done to m? What's going on there? It's multiply. So I need to do the opposite. What's the opposite of multiply? Divide. So if I divide by 4 here, I have to do it. But be careful, because now instead of doing it to one thing, I've got to do it to this whole side. Sometimes we'll have some equations, and it'll be easier for us to solve it for a variable if we are doing, like, let's say that. Yes, absolutely. You absolutely will. This is probably, yes, absolutely. Algebra 1 specifically, yes, that's most definitely. You will, if you are going to do anything post high school, you will need it. All right. Divide by 4, so I have m equals. Now here's where you have to think. Okay? Sometimes I should split this up, and sometimes I should leave it. I'm going to split this up to show you how this works. Now, if you've got multiple parts in the bottom, this doesn't work. It only works when there's multiple parts in the top. But when you have this, you can split up your fractions into this plus this. Okay? You can make that into 2 separate fractions. So you can make this 8 over 4 plus And I'm going to write it this way instead of 3n over 4. It's not wrong if you do 3n over 4. Okay. Why might I have set that up that way? Why might I have split it up?
Because you can.
I can what? Go ahead.
Straight across.
It was adding straight across. I split it up from adding straight across. Why did I do that?
It'll be 3n. Or n equals 3.
How big is all the same? Because you don't need a
Equals 3.
because the denominator is the same.
What is this?
That's 2 improper.
Oh, it'll be
A half.
It's a 2.
If you can simplify, okay, I always want to simplify my answers. Looking here, I noticed that 8 and 4 could be simplified as a fraction, and that's why I split it up, okay? It's probably a good habit to be in to go ahead and be splitting them up when you see it like this, okay?
Oh, exactly.
You may not have seen this before, that's why I'm taking some time going over it. How what? How did I get what? 8 divided by 4 is 2. And then you got through. Anytime you have a fraction, okay? Think about it like this. Let me go backwards with it a second, okay? If I had, and this is totally different, but just to show you, if I had 2/3 plus 5/3, how would you add that together? You would add the top together, but you would leave the bottom the same, right?
Yeah.
All I'm doing is I'm going from here to here instead of forwards. I'm splitting up that addition instead of putting it together. Does that make sense?
No. No.
I could rewrite this as 2/3 plus 5/3.
Oh,
Yep. Shh, shh, shh. Guys. All right, let me show you another one.
Is it gonna be just like that?
A lot of them, yeah. Let's say, guys, let me tell you this. Let me show you this because this seems to be everybody's problem, not the actual solving, but the splitting up of the fraction. Let's say I had um 5 plus 4x over 12. How might I simplify that?
Divided by 4.
5 over 12 plus 4x over 12. Now, I'm going to take that x and put it on the side because as long as it's in the top, I can put it on the side and it makes it a little bit easier. Now I'm just looking, can I simplify these fractions any? Yes, which one? 4 over 12. What does it become? 1 over... Okay, remember this as you simplify fractions. Someone has music playing. David is looking at a phone.
Checking my volume.
Okay, you shouldn't have that in your ear and playing. Yes.
So is that the
That's the I'm just showing you how to simplify because that seemed to be where we got a hiccup there in the first example. Okay, so just simplifying fraction. All right, look, when you simplify a fraction like this, a lot of you are saying 3, and you're not. And before, a lot of you said 1/2. You're getting them upside down. When you do it, you leave it exactly the way it's written, and you divide by the biggest thing you can. Right? So 4 divided by 4 is 1, and 12 divided by 4 is 3. All right, we're going to do several more simplifying examples because all of our examples need to be simplified. But let's do another literal equation.
All right, I'll get
Solve it for n. I'm gonna give you a second to try. All right, I see some befuzzled looks. A lot of us are working. I see some of us staring a hole through our paper. Tell me what you did first to get n by itself. Yes, Xavier. That's exactly right. All right, when I move the 6p, can I subtract 6p from 15? If you can't do it, write it. Okay, so 15 minus 6p. And now I'm going to divide by 3 on both sides because that is going to get my n all by itself, right? Same steps as solving, it's just there's more variables in here, okay? So now I have 15 minus 6p. That's exactly right. I'm going to split them up into 2 separate fractions now. And I'll have
15 divided by 3 and 6p divided by 3.
And I'm going to write that p right outside here since it's in the top. You don't have to. It's not wrong if you put it in the top. But I did this because, look, I can simplify this a little bit more, can't I?
And then 6 divided by
3 over 1 and 2 over 1. 5 over
15 divided by 3, 5 minus 2.
p. And that's why I got stuck at.
But you're done. You're
Oh, I'm
done. That's it.
I'm gonna get that right.
All right, let's do one that looks a little, it's not bad. It's really not. Good. That's going to really help y'all as you get to it in Alex. You'll have already got a little bit of a foundation there before we get. All right, let's look at another one. This one's going to look, they're not all going to look like this. This is just, y'all struggled with this. So I wanted to do several examples. Look at this one. A little bit harder. Solve that for K. Where's K? On the top of this fraction. So let's think SAD map. And remember, fractions group, right? Is there any? Yes, you're exactly right. Good job. Yeah. Well, in this case, since we're not simplifying yet, since we're solving, we're going to do the opposite. So what we're going to do, since all of this is divided, we're going to multiply both sides by 5. Now, can you multiply 11j and 5? Yes, okay. You can't add them unless they're like terms, but you're welcome to multiply them. Multiplying doesn't have the same rules, right? I have k minus 2 equals, what does that become? 55j. You can multiply by 5. Because multiplying, you can multiply the numbers together there and smush them together, but you can't add them together. Or subtract them, right? Yes. Close. Instead of subtracting, I need to do the opposite to get rid of it. So I need to add. Now, can you add 55j and 2? No, because that 2 doesn't have a j on it. So I can't do it, so I write it. Yes.
So that's just the whole answer.
Hold on, because we're going to do several more of these get sticky. Now, Before you jump to doing what you want to jump to do, and I know what you're wanting to do, before you do that, I want you to look at the problem. I'm solving for t. What is being done to t? It's multiplied to all of this, right? Could you get rid of all of that at one time? How?
You could do R, R.
Could I do this? Is that legal? Sure it is. I can divide by whatever I want to. I need to make sure I keep it chunked together in that parentheses though. As long as I do that, look how easy this problem became. As long as it's in parentheses and it's all together, you can move it all together. Okay? So you can move whole chunks if you need to. That makes it convenient. Now, I'm not splitting up here because notice the plus is where? In the bottom of the fraction. I can't split it up. Good job. Good vocabulary. I can't split it up if it's in the denominator. I can only split up if it's in the numerator. Okay? So in this case, I would leave it as is. What if the variable I was looking to solve for was inside that parenthesis instead of outside? So what if I wanted to solve for Q here? Do I do the same thing here? I don't know. If I divide by Q minus 8, I'm moving the Q. The Q is not what I want to move. What is it that I want to move? Everything else, right? I want the Q along. So what could I do? Think about SAD map here.
So I'm gonna get, so you could add a almost like
All right. What comes last in SAD map? Okay. Is there anything outside of those parentheses that you can do? The A. How could I get rid of that A?
Distribute it.
Get rid of it, not
Divide.
divide. Sure. The reason I can do this now is because these parentheses are keeping the Q and the negative 8 together there. So I can divide it here because look, parentheses comes last. And everybody wants to add, but that adding comes inside that parentheses. So I can't add first. First I have to take care of that division part here, right? So I get Q minus 8 equals 23 over A. I know this is hard, and it's hard because it's not what you're accustomed to getting when you solve an equation. That's what makes it hard. What now? Add 8. Can you add 8 to 23 over A? No, because there's an A in here, right? So I can't do it, so I write it. Yes or no? No. We'll do a few more. Look at this one. All right, this one we're really going to have to think, okay? Put your big boy and girl panties on. Here we go. How is this one different than the ones that we've been doing? There's variables on both sides. There's two variables beside each other. What else?
There's two of the same.
There's two of the same variable on opposite sides of the equal sign. And it happens to be the variable that I'm trying to solve for, right? So I want you to rewind your thinking for just a minute. And we did a section on solving equations with variables on both sides, right? What was the first thing we did when we solved an equation that had variables on both sides? You subtracted the lesser of the two. That's right. You moved the lesser of the two and you got the two that went together. Okay? We're going to do the same thing here. Only I don't know which is the lesser of the two because one is 3 and one is z, right? I don't know which one is the lesser, so I'm just going to move one of them. In this case, just because I like to be on the left side, I'm going to move the xz. Now, I want you to stop here and think for just a minute. When you combine like terms, because these are like terms, do we all agree? They have that same x variable. If I had, let's say I had 2x plus 5x. Tell me how you combine those. You add that's multiplying, but how do you add 2x and 5x? You just add them, right? Would you agree that you do 2 plus 5 and then you take it to x? And it gives me 7x, right? But do you agree that this middle step here is what you do? You just do it in your head, right? You agree with that? Could you do that same method to add 3x minus, and I'm going to rewrite this as zx so you kind of see what's going on. Could you do something similar to this to make it look that way? Look at what I did on the right with the parentheses. Could you do that? You will still, and we'll get to that, Shay. But right now, can you combine the like terms here?
Yeah.
Do it. What do I do? 3 minus z is going to be in parentheses, right? X. Everything else stays the same. I just did the same thing that I did over here that you normally would do in your head, but because there's a variable there, I really can't do it in my head, so I write it. Does everybody see what I did?
Somewhat, but I'm still trying to do.
Because here's my thing. When I solve it, I can only have one x whenever I solve it, so I got to get it down to one x. I know that this is tough. Okay, this is really tough. This is about as tough as it's going to get with these. So y'all stay with me, and I'll do one more too. Now look at it. How do I get x by itself? Add 2y. This is still here exactly like I did. 3 minus z times x equals, can I add these two together? If you can't do it, write it. Right? Now how can I get x? How can I get x by itself? Divide. That's exactly right. This looks terrible.
It's like a horrible game, man.
See why I wanted to split the section into 2 days? This is half of it. Yeah.
Yeah, like give us a little bit of homework.
Let me do one more like this before I set you loose. Shh, shh. One more.
Hold on, wait.
All right, here we go. Last one. Solve it for Q. Tuesday. Interims are Tuesday. Okay, let's walk through this together. This one is different because the variable that I'm solving for is in there more than one time, right? So I have to get them together. So subtract QR, you're exactly right. QR. QR. Minus, I'm going to write it as RQ so that you see that they're like terms. Because multiplication I can do in any order that I want to. I hope everybody at least got to this point. Okay. Because the next part is where you really have to understand like terms to understand what you're doing. And really, you're doing a little bit of a higher level math here, and that you're doing a little bit of basic factoring here, which we will get to.
This thing got done on homework.
Yeah. All right. Now, a lot of the ones on your homework won't have a variable there. It might be 6Q minus 2Q instead of RQ. Okay. All right, so looking at those two terms, if I write them like I'm combining like terms, I need to do 6 minus R times Q. Is that what you got? Now this looks like something you can work with now.
So you multiply it by using separate
Yes. Well, it's because that's what you do with like terms. You add the numbers in front and then you put the variable on it. So I'm doing the same thing. I'm just doing it in parentheses in front. Now what do I do to get Q by itself? Plus 18. Can I add T and 18? No. So I just write it. And then what?
Divide 6. Divide by 6.
And I'm done. That's all you have to do. It's not a lot of arithmetic in it or a lot of any of that type of stuff. It's really just moving things around and rewriting them.
Oh, arithmetic.
Arithmetic, it can be either way.
'Cause,
All right. Let me give you your assignment.